This will be our third video for 4C, which is mixed factoring. You can see in this first one, it was in descending order. There was a GCF, so I took out a U. Then I'm going to count the terms, 1, 2, 3, and I'm going to do the AC method. So I'm going to pause it and do that for you. All right, so I did 1 times 27, got 27. I chose 1 and 27. They multiply to be that, and they add to be 28. So I split my 28 into 1 plus 27. These are both U cubes. Then group 2, U to the third came out, left me with U third plus 1, and then 27 came out. 27 left me with U to the third plus 1. So I brought my U on down, and I have U to the third, my matching parentheses, and then I'm left with U third plus 27. Now I want to look at my parentheses, and I note that they are the sum of cubes, both of them. And so then I am going to factor those, and I'm going to pause it and do that. And here are the results. This factors into U plus 1. Here's my second parentheses. This factored into U plus 3. And here's my second parentheses. Watch the signs. All right, this next one, example F, a to the 6 is a term that could be written as a square. So I could say it was a to the third raised to the second power, or I could say that it was a to the second raised to the third power. So you see, this could either be the difference of two squares, or it could be the difference of two cubes. And this says factor is the difference of squares first. So this will be a to the third squared minus b to the third squared. So when I factor that, it's a to the third minus b to the third, and then a to the third plus b to the third. Kind of difficult to look at, right? So then notice that these are both then cubes, and I'm going to factor them as well and pause it. Notice that when we did do this as a difference of squares, that when I take the square root of this, it is half of it, a to the third minus b to the third, and a to the third plus b to the third. All right, so here I've done the cubes, where I've taken the cube root, long parentheses, cube root, long parentheses. All right, so now we have 4 terms, and there's no GCF. And if I were to try and group 2, you can see I'm not going to have matching parentheses when I remove the GCFs. It's not going to work with a group 2. But if you look, these first 3 can actually be factored with an AC method. It's a special AC. This is a perfect square, and this is a perfect square. So 3 times 3 is going to be 9, and 3 plus 3 is 6. So this factors into a plus 3, which is written as a plus 3 squared. So I have a plus 3 squared minus c squared. So now, so this was a group 3 on this one, group 1. So now notice I've got 2 terms, 1, 2, they're both squares, and it is a difference. So this is now the difference of squares, and that's the way I'm going to factor it. So I will take my 2 parentheses, I will take this a plus 3 and put it in both of these places. And then remember that when I do it, one of them's a minus and one of them's a plus. And then it's going to be C in both of these. And there's no simplifying that can be done. And that is my answer. We're going to do the same thing for B. Again, you will not be able to do it 2 by 2. So I'm going to group 3 on this and group 1. Again, you see that this is a perfect square, 5x times 5x. And this is 2 times 2. And if I were to FOIL this out, I'm going to write it this way, 5x plus 2. If I were to FOIL this out, I'm going to get 10x, and 10x is 20x. So that factors, and I will write it as a square minus 16y squared. Now it's the difference of squares, so div S. And when I make my parentheses, I will take the first one, 5x plus 2, and put it in front for both of these. And then I have a minus and a plus, and then 4y in both of the seconds. And this is my answer. Done.